Some AI experts have downplayed the technology's potential to replace employees and reduce payrolls, but many IT leaders have a different vision, with more than half saying that they expect AI will enable their organizations to cut jobs. Now, 53% of IT leaders surveyed for the 2025 AI Priorities Study from CIO.com parent company Foundry say they believe AI capabilities will enable reductions in their organization's workforces. Hello, everyone. Welcome to the Analytics Insight podcast, where we talk about the ever evolving tech space. And I'm your host, Priya Dialani. Now, every tech conference these days pushes the same lazy narrative: AI will replace software engineers. Consultants sell it, journalists repeat it, and C suite leaders believes it. But they are wrong. AI doesn't reduce the need for engineers but multiplies it. And how it does will be explained by Radha Krishnan, president and founder of Detroit Engineered Products, in today's podcast discussion. Hi, Radha Krishnan. How are you doing?
Very good. How are you?
I am good too. Thank you for your that you've taken out time to be on a podcast today. And I believe that we'll be having a very interesting discussion because there's a lot of debate and going around. I mean, we have been having this debate since a long time with the emergence of AI that it will replace humans. And considering the software engineering market today, there's this hype that's coming up that it will replace software engineers. But I guess here you are today to give us the other narrative and help us understand that it's not going to replace, rather multiply their capabilities. So, Radhakrishnan, let's start by telling our listeners more about Detroit Engineered Products. Our listeners would like to know more about the organization and its specialization.
Great. First of all, thanks to Analytics Insight for giving us this opportunity to share our experience with your podcast audience. First of all, DEP or Detroit Engineered Products. We are a design, engineering, and software company. We are headquartered in Troy, Michigan, in the US. But we have offices in India, China, and Japan, and we have our partners in Europe and other geographies. We are today a 550 engineers strong company, mostly advanced degree holders like masters in mechanical, electrical engineering, and computer science, and PhDs as well. And as a company, we are in a specific industry, which is the product design and development, whether it is an automotive product, aerospace product, heavy equipment, consumer goods, wherever actual products are being developed, we play in that product design and development arena. And we do two things. One, we do simulation-based engineering. We simulate the mechanical and electrical behavior of products, like a full car or a full airplane, etc., way ahead during the design and development before the hardware is produced. And we virtually validate whether the design is going to pass or fail, and accordingly improve the design. This is one activity we do. We also have a software division which has created our flagship MeshWorks platform, which is a key enabler to creating these simulation models. So obviously you need high-end software to create these virtual models with which you can predict the behavior of all the products that you're designing and developing. So whether it is on the engineering services side or our MeshWorks software platform side, the end users are all these organizations like a General Motors, Toyota, Maruti Suzuki, Ashok Leyland, Volkswagen, etc., all over the globe. These kind of customers, both automotive and non-automotive, use our products and services in order to speed up their product design and development time. And the MeshWorks platform that I was talking about has the key AI module to it, which will be a major enabler to processing simulation data. More about that we can discuss as we go along. So this is about DEP, Detroit Engineered Products, as an organization and as to what we do.
Great, thank you for that overview, Radha Krishnan. And I am glad to understand how DEP is positioning itself at the intersection of innovation and real world impact. From what you have shared, I think it's clear and evident that your specialization of combining designing and engineering goes beyond just offering a product or a service, but it aims at solving meaningful problems and creating measurable value for your customers. Having said that, we would also like to know more about you. You have over 30 years of experience working with and leading tier one automotive companies, as well as OEMs, and you truly understand what it takes to create revolutionary solutions that the global automotive industry needs. So, we would like to know more about you, Radhakrishnan. How has your journey been till date? Incredible 30 years, I would say. And what is your role at DEP today?
Sure, I'll be glad to share that. I'm originally from India. I did my undergrad mechanical engineering in IIT Madras and then migrated to the US, got my master's degree in mechanical engineering from the University of Ohio in Toledo, and then worked at General Motors in Detroit, Michigan during my initial years. And I was part of the electric vehicle one, EV1, way back. And that was the first modern electric vehicle to be produced. And then I quit GM and started DEP, Detroit Engineered Products. And ever since, it's been quite an exciting journey, and we have steadily grown to where we are today. And my specific role in the organization, besides the general administration of the company and direction setting and path setting for the company, a big chunk of my time goes into the technology development. So I head all of the technology areas in the company, coming up with new exciting tools, how to apply AI to simulation data, how to come up with new interesting design engineering processes that can add significant value to our end customers, which is bringing the product to the market very, very fast. The same vehicle, instead of taking 3 years or 4 years to bring to the market, can we bring it in half the time, in 2 years? So that's a big value that we want to bring to our customers. I play a role in designing and developing tools and processes that would enable that. And at the same time, whichever product that our customers work on, it could be all the way from a consumer good like a tennis racket, or a very complex product like an airplane or a heavy earth moving equipment. The entire product needs to be optimized to meet its performance targets and cost targets and weight targets. So how to optimize the product. So that is also an important area that I do participate in coming up with new technologies, and how to apply the technology to new areas during the product development where today there is no solution. So especially during the early stages of a product development, when design evolves very rapidly, today there is no good solution to assess the performance of the design. So that's where enter AI. So our special way of bringing in AI to assist during that early product development phase is at another major area of my focus in the company at the present time. So overall, I would say my time is spent quite a bit in setting the direction of the company on the technology front, and also at the same time help the organization deploy these technologies to our customers worldwide. So this is how I would describe my role. Besides the exciting part, which is interacting with all the employees every day, I would like to say I'm quite hands-on with respect to that aspect as well.
Glad to know, Radha Krishnan, and I'm happy to see how your role and your contributions sits at a very interesting intersection of strategy, execution, and innovation, wherein you're not just closely involved in shaping the vision, but also translating it into real and measurable outcomes for the company. With that
Sure.
foundation set in place, Radhakrishnan, now many organizations are rushing to implement AI, but in their haste, they are often making developers' lives harder and not easier. It's because the interaction surface area between a developer and the AI isn't making the developers' jobs more enjoyable and more interesting. So, this friction stems from a fundamental misunderstanding of how to apply AI effectively in a development workflow. Now, as artificial intelligence is reshaping every other vertical, it is also reshaping software development. And engineering leaders are at a crossroads. One path leads to the accounting mindset, where AI is a tool for cutting costs and developers are viewed as expenses to be optimized. So there's a persistent fear that AI will replace engineers. From your experience, why is it more accurate to view AI as an engineering force multiplier rather than a headcount reducer?
Great question. I've been asked this many times. And based on my personal experience as well as our company's experience and the everyday interaction that we have with our customers, whether it's a General Motors in US or a Toyota in Japan, or a Maruti Suzuki in India, name it, or a Dassault Aviation in Europe, or CNH in Chicago. Wherever we go and interact with customers, there is this general excitement around AI, especially in the design engineering community. Okay. So whatever I'm going to share in the next few minutes is this collective experience of my interactions with our own software development team, our own design and engineering team, and with what is going on around in the industry. Okay, I'm of the very strong opinion that, especially in the design engineering field, AI is definitely going to be an engineering force multiplier and not the other way around. Okay, this is my personal strong opinion based on my experiences. I cannot talk about other industries. I have only limited view of my own industry. All right. So speaking based on that experience, it is definitely going to be a force multiplier. And I'll tell you how. Okay. First and foremost, if you take the early design development phase, let's say you design a tennis racket, or let's say a stent that goes into the heart of a human body for fixing a block, or a complete automotive vehicle development. No matter what product you are designing, during the early stages of the design and development, designers give shape to the product. In many ways, you can treat them as the creators. These are mechanical and electrical engineers who give shape to their product. But when they are giving shape to the product, the design ideas are overflowing. Everyone comes up with bright new ideas, and designs keep getting modified almost multiple times, even in a day. Okay, let alone over a month period or 2 months period. It's a bubbling up of several different ideas from the entire design team. And by virtue of that, the designs evolve very, very rapidly. So, and during this rapid development time phase, which I'll call it as the early product development phase, one key question is always asked: will the design pass or fail? Yes, I'm giving a shape to my design, but I don't know if I'm developing this car and if it gets into a crashworthiness situation, will the occupant be protected at a 50 miles per hour or 35 miles per hour situation? Will the occupant be protected? Even though I've given shape to the car, I wouldn't know whether the design will pass or fail for a criteria like that. Likewise, there are literally a few hundred criteria that the product needs to pass. And for that, today, even though simulation-based engineering is there, it takes a long time. If I were to solve the same problem of crashworthiness, I need, once the designer has given a shape to the car, literally easily about 2 months of 20 engineers working nonstop to give me that answer, whether the design will pass crashworthiness or not. So if I wait for 2 months, by the time the design itself has evolved 10 times. So pretty much by the time I'm ready to go and give my results, it becomes obsolete. Okay. Now enter AI. Okay. With AI, I can train on my historical data. I have a lot of simulation data in my organization. If you take a large organization, like a large automaker or aerospace maker, they are not operating in a vacuum. They have their historical data of the last 10 years, 15 years, who knows? And all that data can be trained, that simulation data done earlier on previous designs can be trained, and I can get my AI models generated. Of course, there's an initial investment needed, but I can create those AI models. And with that AI model, the same that my designer gives me this morning, in the afternoon, I can go back to him by running the AI model on that design, get its crashworthiness performance. And likewise, there may be many other criteria, aerodynamics criteria, which is meant for fuel economy, et cetera, et cetera. So there may be several criteria. All of that I can run with my AI models on the design the same day, and end of the day, I can go back to him and give a scorecard report. Okay. This was not possible earlier. Of course, a lot of work is, initial investment is needed to create this family of AI models. But if I do create them, okay, then I'm in business. I can apply them onto a new design, and I can guide the design team saying, hey, this design is going to pass for this 5 criteria, and for this next 10 criteria, it will fail. Now the design team will go and modify and come back to me the next day. Now the AI tools can be again applied. Keep in mind, this whole AI-driven design guidance was not there earlier, before the AI tools were developed. So now we are creating a new space or a new market, all right, for AI tools to be applied during the early design and engineering phase. And the tools may not be super accurate like your traditional simulation tools, physics-based simulation tools, but that is okay if you can get a directional answer that is far better from AI tools. That is, if you can get a directional answer from AI tools, that is far better than not even having an answer. Okay, which means AI is nicely filling in a void, which means I can imagine a new set of engineers who will apply such AI tools, which is a force multiplier, who can drive this early design and development phase. So this is one part of the story. This is the application of AI tools part of the story. Now let's talk about the software engineers. What about them? We, being a software development organization, we have a team of software engineers who do the coding, who design the code, who implement the code. We do C++ programming, Java programming, blah, blah, blah. All that stuff we do, all right, because that's the basic implementation methodology, all right. But then at the same time, there is this question asked, Today, generative AI can help in generating code. Why would you need the developers? Okay. All right. We do not look at it that way. All right. Rather, any software organization has, in a realistic scenario, has 10 times more volume of tools that they have to develop than the kind of capacity that they have today. Okay. The way I view our software organization to be adapting to AI tools to enable in their software program writing is that in a typical year, they write, let's say, 100 tools in our software platform and deploy it. Today, they can literally create 500 new tools in the same space enabled by the AI code writing. Okay. So this is the reality. There is no software company in the world I can vouch for who will say, I have this year only 100 tools, and after that, there's nothing in the pipeline. It's far from the truth. The amount of volume of work that is there in every software organization far exceeds the capacity they have. So, in that regard, also, I believe, and plus with the code generation, you can also bring on board additional developers. I'll tell you how. A lot of times, we being a software development organization, when we hire a new engineer with a master's degree or undergrad degree or a PhD from a university, it takes an initial good 6 months for them to be up to speed in what we call as the tools, which is a C++ or a programming language like C++ or Visual Studio, etc., etc. And only after that, they become productive in the implementation. That entire 6 months now can be shortened quite a bit thanks to the AI-driven tools. Now, the same developer can focus more on the algorithm development of a new function, okay, as opposed to spending the time in the code writing. So, the creative part of any software writing is in the requirements part and in the algorithm development part. Okay. So this is where the developer's job description itself can be redefined, and more developers, I believe, could be added faster through this route as well. So whichever way you look at, either during the early stage of the product development or the software programming side, my viewpoint is that this is only going to add more to the workforce. Okay. And the end result would be the users, which is the customers. They now have the ability to get newer, faster solutions in a much more condensed time frame.
That's a really important distinction you have highlighted. And I think AI isn't removing the need for engineers, it's actually raising the bar for what engineering teams can accomplish. And by offloading repetitive, low leverage tasks, AI is giving engineers more time and mental space to focus on architecture, problem solving, innovation, and system level thinking. I think the real conversation isn't about fewer engineers, but we need to focus more on empowering them and about how engineering itself is evolving in an AI native world. Moving ahead, now of course we discussed about the role of AI, but there's a constant tug of war inside AI models where they are focusing on whether they should go fast or whether they should be right. Now, at its core, the trade off is pretty simple. An AI model's quality or accuracy refers to how good it is at its job, how correctly it identifies a cat in a photo, or how coherently it answers a complex question, or how bug free its code suggestions are. This accuracy often comes
Mhm.
from making the model bigger and more complex with more layers and parameters. So it's kind of like giving it a bigger brain. But that bigger brain needs more time to think. So, speed in the AI world usually means the inference latency. the time it takes for the model to give you a response after you have given it a prompt. A more complex model with its billions of parameters naturally takes longer to generate that response. It's like asking a simple question to a casual friend versus a panel of philosophy professors. So you will get a faster answer from your friend, but the professors will hopefully give you a more thorough and a nuanced one. So this is often trade-off assumed between speed and quality. How does AI help engineering teams improve both simultaneously?
All right. First, let me, again, I'll give it as a two-part answer. One, addressing the pure software code writing part of it, which is, let's say, AI enabled. And the second one is a user of an AI tool for doing the simulation. Let's talk about the developer part of it first. Based on my understanding and interactions with our own development team and external developmental teams, a lot of these generative tools which generate the code have reached a fairly good level of sophistication, wherein the code generation, even though it may not be 100% accurate, who knows, it may be 90% there. Okay. But that itself is a big step up. So if I'm a developer, I now already have something to start with. Okay. I'm not going to just take the AI generated code at face value and right away I'm going to integrate it into my overall framework and commit it for production purposes. I won't do that. I rather would go through the code and do my own edits, all right, and updates. And of course, it goes through the complete testing process, quality assurance process, all that remainder part of the software development cycle that no one is going to skip, okay? At best, it is going to give you an initial booster shot by way of giving you a starter code, if I will, so that the same developer can hit the road much faster. Okay. So will it be 100% accurate? Probably not. Okay. Is it 90% there? Probably yes. And that initial stage of the time reduction is definitely going to be noteworthy. Okay. Now let's talk about the simulation side. Okay. Like the crashworthiness example I gave, or aerodynamics example I gave. So there, the quality or the accuracy of the prediction, is it going to be as good as a physics-based simulation? Definitely not, because the AI fundamental idea is data-driven. It is learning from past data. Okay. So it can never be as accurate as a true physics. Okay. So the way the AI should be viewed in this context for simulation is for directional guidance. Okay. And also when you train on the data and create the AI tools for an aerodynamics prediction, you need to also design the data to suit your purposes. If you're a vehicle maker who's manufacturing only SUVs, okay, then there is no point in bringing sedans or pickup trucks data and trying to create an AI model. So you are going to customize it for your needs with that kind of data. Then the AI model becomes more accurate and of a higher quality. All right. So there are a lot of checks and balances, like in any industry or in any technology, there is the technology and there is the right way to use it. So if the AI is applied correctly to the simulation data, then you will reap the benefit of a more accurate model. Okay. So that is how this needs to be viewed by way of speed versus quality.
Definitely, and that's a really powerful perspective. And I'm glad to understand that AI is fundamentally challenging the old belief that speed and quality sit on opposite ends of the spectrum. And I think by embedding intelligence into the different stages of development, AI becomes a second set of eyes for engineering teams, and wherein developers can focus on higher value problem solving. And eventually, I think the successful integration of AI into engineering is ultimately a test of leadership. It's built on three pillars: a foundational commitment to the developer experience, a strategic shift in focus from efficiency to value generation leverage, and the use of metrics as a tool for coaching and enablement and not evaluation. So, this fosters a high trust environment where innovation can flourish. And I think that. As engineering is becoming more complex, but it is also becoming much more exciting. Used well, AI tools can turbocharge the creative potential of individual engineers. However, human engineering judgment will remain as critical as ever. Engineers will need to be multidisciplinarians, mastering both their domain of specialism as well as the fundamentals of the AI models they use. Well, thank you so much, Radha Krishnan, for taking out the time and effort to be on our podcast today and helping us understand that AI should not be about tuning for efficiency or for reducing headcount. Instead, we should be talking more about using AI or as maximizing the value generation leverage of each engineers. I think the goal becomes more on amplifying the value each developer can create, probably by exploring more product possibilities or investing in quality improvements and other developments. Thank you so much, Radhakrishnan, for your insights. It was lovely chatting with you.
Great. Thank you so much. My thanks to Analytics Insight as an organization for giving us this opportunity. And I hope I was able to share my perspectives based on my organization, which is Detroit Engineered Products Perspective. Thank you.
Thank you so much. So, this is for our
Thank
listeners.
you.
I hope you enjoyed today's discussion around how AI is actually empowering engineers to take up new innovative tasks, and by fostering a symbiotic relationship between AI and human talent, we can unlock unprecedented levels of innovation and efficiency. Stay tuned for upcoming podcasts, and you can view all our previous episodes on Spotify and other leading platforms. Thank you so much.